Hi, this is Tarik Rashid, class at Advanced Artificial Intelligence, Naive Bayes. This is part two, as always promised. That part two will be kind of a practical of an algorithm that we explain. We'll try to talk about some historical background of this beautiful algorithm. It was developed by Thomas Bayes in the 17th century, and then later on Pierre Simon Laplace formalized and extended the idea, and it became in 1990s very popular for spam filtering, text classification. If we are giving a set of data or data set, we will have features, x1, x2, for example, weather and humidity, and the class is either yes or no. So, and what is the goal is to predict class using naive based on the Bayes theorem. This is our data sets. We have two features, weather, humidity, and class is play. Either no or yes, two values. Humidity, two values, high or normal, and weather has three values, sunny, overcast, rain. There are 7 samples. So the mathematical model will be finding the probability for feature 1 in that class based on the class, and finding it for all classes and multiply them by the probability of the class if that class is yes or no. So here probability for yeses on those samples, we have 4 samples for yeses, 1, 2, 3, 4, and we have 3 samples for no, 1, 2, 3. So for yeses, 4/7, because we have 7 samples in total, 4 of them yes, and 3 of them no, over 7. Here, the probability of sunny feature in the yes class, we will have nothing sunny if we look at here. In the sunny, we don't have anything, nothing, but it's 0. But how many yeses we have in the data set? We have 4 yeses. Now, probability for sunny, no value, no classification, no class, no, I mean, we have 2 no's in the data set, and overall, over 3 for sunny, we have 2 no's, but over 3 no's the whole data set. Likewise, overcast, we have yes, 2/4, 2 yeses for overcast, but the number of yeses in the set is 4. Again, we have to do it for overcast. For no, we have no samples for overcast no, and we have 3 samples where you play no, so 0/3. For the rain, how many yeses we have for the rain? If we can go back, yes for rain, yes for rain, and 2 yeses we have, but so 2 yeses we have, so 2/4, 2/4. And how many rains we have? No, 1 no we have for the rain. And how many number of no's? 3 no's in the data set. So sorry, if we can go back here. So rain, we have rain, 1 rain no. That rain is no. And how many no's we have? We have 3 types. So we have 3 no's, 1, 2, 3. But this one, no for the rain. So no for the rain over the number of no's that we have in the plane. Likewise, we can do for humidity. We have yes, 2 yeses in high, over 4 yeses in the whole data set. That is done. Sorry, here, that is done. And high, we have two no's for high, but over uh, uh, three no's that we have. So high, actually, we have four samples of high, by the way. That's one, that's two, that's three, that's four. That's four, sorry. So two yeses we have, 2 over 4, and 4 no's, 2 no's we have over 4. I think done. And likewise, we do for normal. How many yeses we have? 2 normal, and over 4 yeses that we have, the whole total yeses, and 1 no we have for normal, and over 3. So 1 no, where is normal? Here. No, this no is normal. And how many no's we have? 3. So 1 over 3. Now we are trying to find the probability of yes for the sunny, which is 0. We don't have any sunny yes, sunny with value yes, play. And probability for, therefore it's 0. Now, let us have a test case in here. That's the test case. If we have features are coming with sunny and high. So how we are trying to get the class. So we'll see. Um, for the sunny, we don't have sunny, 0, sunny over 4. 4 samples are yes. For no, four samples we have for yeses. If sunny is yes, so we don't have sunny is yes. But how many yeses we have? We have 4 yeses in the sample data set. But how many of them sunny yes? We don't have 0. Now, multiply by high. High. How many highs we have with yes? 2. But how many yeses we have in the data set? 4. Now, multiply by probability of samples of yeses over the total samples of the data set. Total samples of data 7. And how many of those 7s are yes? 4 of them. So this whole will make it 0 because you have 0 here. So this whole 0. And we do same thing, sunny and high, but this time we take the no value. The no value. So we took 4 years value, both of them. We took 4 years value, both of them. Now we take for no value. For no value, the no for sunny 2 no's we have over 3 no's in the sample. For high, we have 2 samples. Remember, we had 4 samples of high, but 2 of them are no. 2 over 3, because 3 no's we have in total no's in the data set, multiplied by total numbers of no's, 3, over the number of the samples that we have. Total no's, no samples in the data set when it is high over 7. So here we'll find that 4 over 9 multiplied by 3 over 7, this will give us 0.97. So the prediction is no. Why? Because no greater than 0. So that was taken no. Likewise, we can do it for case 2 if we have rain and normal. How many rains we have? 2 rains we have with yeses over 4 yeses in the sample data set. Now, for the normal, 2 normal we have, their values are yes. 2 yeses in normal feature. And over 4 yeses we have. Now, again, 4 yeses in the data set over the whole sample, 7 samples we have. So that's 0.143. Let's do the same thing. That was for yes values. That was for yes values. We're going to do for no rain and no normal no and rain no. So rain no, 1 sample we have it no in the rain over 3 samples of no in the data set, multiply For the normal, we have again one no in the normal feature for humidity, and over 3 no's we have in dataset, multiplied by number of no's in the whole entire dataset over the entire dataset samples, which is 7. So you'll find 0.08. Now again, we will select this one and we don't select this one because this value is higher. So the prediction is yes. Um, you can test overcast and high if you're 2 features. You can select, you can have weather is rain and high is humidity. And you can do test for self-test. You can do for sunny and normal and see the prediction results. I think that's all about today's class. Naive is very powerful progressive model and assume feature independence. It works well even with small data sets, sensitive to 0 probabilities, so someone can solve that one, and easily extendable to multiple features. Thank you very much. If you have any question, please drop me an email from my website and stay tuned for next class. Thank you.